Hello, and for this video we're going to be looking at some grade 9 questions that they're the last questions which shown up on a few GCSE papers. As we can see here on the screen, we are just looking at paper 1 today. I'll be making other videos on paper 2 and paper 3, but for now we're looking at paper 1. So these are just the last questions on the last few papers, so from 2022's exam, 2023's exam, and the mock in 2023 as well. So if you can do these questions here, you're on a good start for getting your grade 9. And for this video, I'm going to go through all three of these in a bit more depth. Hopefully some of them will, once they have been explained, won't be so daunting as they seem. As you can see there, the bottom two are 4 marks and the top one is 5 marks. That's definitely one of the harder questions I've seen, but hopefully with an explanation it shouldn't be too daunting. What I would recommend if you're watching this video and you are hoping to get your grade 8, grade 9 is pause the video and give these questions a go. The order which I'm going to be doing them is I'm going to start from the bottom and work my way up. So the first question is going to be the geometric sequence with the surds, and then the last question I'm going to be doing is the circles question. So if you want to pause and do the first one and then unpause, see how I run through it and see how you've done, and then pause again and give the second one a go and so on. That'd be a good way to do it, or pause, just do all three. But that's the best way to learn, is make some mistakes and then see how it's properly done and then give it another go as well. Make sure you're understanding properly the methods being used. Okay, so hopefully with that out of the way, we can have a look at how we can make a start on getting our grade 9. So let's look at this first question. So we have the second term of geometric sequence is 3 plus 2 root 2. The third term of the sequence is 13 plus 9 root 2. Find the value of the common ratio of the sequence. Give your answer in the form a plus root b, where a and b are integers. You must show all your workings. So this question, it is quite daunting to begin with. I get that. Common ratios is and geometric sequences. Well, geometric sequences we hopefully will know, but then doing it with roots and surds, it's a bit intimidating. But once we set it up, if you are aiming for that grade 8, grade 9, I suspect that you should be able to solve this question once the initial setup is done. So we want a common ratio. Ratio is another way of showing proportions, right? And we have the third term and the second term. We want to find the common ratio between them. So the way we set this up is as a fraction. 13 plus 9 root 2 over 3 plus 2 root 2. So what do we have here? We have a surd which we need to rationalise. Hopefully we remember how to rationalise our surds, but if not, let's just go through it. So we do not want surds on the bottom of our fractions. So what we need to do, this is our surd we begin with, and we want to multiply it by the antithesis of it. So minus root b is going to cancel out the surds on the bottom, but because we're multiplying the bottom, the denominator, by it, we then need to multiply the numerator by it as well. So let's first worry about the denominator. So 3 plus 2 root 2 multiplied by 3 minus 2 root 2, and then let's expand that out. So 9 minus 6 root 2 plus 6 root 2. We can see there where they cancel out. And then 2 root 2 times negative 2 root 2. Well, we know it's going to be negative to begin with. 2 times 2 is 4. Root 2 times root 2 is 2. 4 times 2 is 8. So we know that these cancel out here. And we're left with the 9 take away 8, which leaves us with 1. So that's going to be our denominator. That makes it nice and easy. And now we just have to do the same with our numerator. So 13 plus 9 root 2 multiplied by the same a pair of brackets which you multiply the denominator by, not 13 minus 9 root 2, because we have to multiply them both by the same amount. Okay, and then we expand these brackets. 13 times 3, 39, minus 26 root 2, plus 27 root 2, and then minus 36. Okay, then again simplify this. 39 minus 36 is 3, plus root 2. So that's our numerator, and if we put it all together, our denominator was 1. 3 plus root 2 divided by 1 is just 3 plus root 2. So if we look back at the question, give your answer in the form a plus root b. That is our form a plus root b. If you want, you can write a equals 3 and b equals 2 as well. And there we have it. That would be our 4 marks there. This is just rationalizing surds. Hopefully, it can be a complicated topic, but if you stay vigilant with your factorizing and expanding of brackets, and you're familiar with your surds, that should be a fairly straightforward 4 marks. The most intimidating thing about this is probably what gets the extra mark compared to the 3 mark, which if they just said simplify this fraction, rationalize this fraction, is that you have to decipher what they actually want. But what I would be thinking, if I saw this question and I saw 2 surds like that, and then a common ratio, well, I know ratio is proportion, and I have 2 surds, it's probably going to be rationalizing. Okay? Alright, so that's question 1. Question 2. Let's have a look at that. So find the set of possible values for which 4x squared subtract 25 is less than 0, and 12 minus 5x minus 3x squared is greater than 0. Which must show your workings. So we're dealing with inequalities now. So first things first, forget about the inequalities. Just solve them. They're normal quadratics. Just try and solve them. So let's start with the left-hand one first. So 4x squared minus 25 is less than 0. And then we want 4 times 25 is 100. So we want 2 numbers that time multiply together to make 100 and add together to make 0, because we have a 0x there, right? Just because there isn't an x doesn't, it's 0 x's. So it's going to be 10 and negative 10, because it's a minus 100 as well. It's a negative 25. So what we're going to have 4x squared plus 10x minus 10x, because 10x, subtract 10x is 0x, minus 25, it's less than 0. Again, don't worry about the inequalities yet, just solve the quadratic. Factorize this out, so 2x plus 5, and then minus 5, 2x plus 5. Remember, these two pairs of brackets here should match up. And then 2x minus 5, bring the coefficients together, and then 2x plus 5. If we just do a quick check to see if it matches our original quadratic, 2x times 2x is 4x squared, minus 5 times 5 is negative 25. We're on the right tracks. Okay, so that's less than 0. So now let's think about the inequality a little bit. If we think about it in terms of a graph, our parabola, and how it's going to look on there. So if we draw our graph, and then we know our roots are at, well, let's solve it first actually. So it's going to be x equals 5 over 2, x equals negative 5 over 2. So we know our roots are going to be at 2.5 and negative 2.5, and then the y-intercept is negative 25. Let's draw it out like that. So 2.5, negative 2.5, and if you want, 25 there. Okay, and because it's less than 0, we want to find the areas where it is in between it. So in this case, it's going to be this. So it's going to be in between those, and we could write our answer in our inequality as x is less than 5/2 but greater than negative 5/2. Or you could write it as the decimals as 2.5 and negative 2.5. I'll keep it as the fractions for now. Okay, so we've solved the first quadratic. Now we just need to do the same with the second. So it's 12 minus 5x minus 3x squared. So 12 minus 5x minus 3x squared, and that was greater than 0. Okay, so with this quadratic, our coefficient of the x squared is negative, which is fine. We could solve it like it is, but personally, I'd quite like to make it positive. So if we make it 3x squared, so we divide it all by negative 1, or we bring it to the other side of the inequality sign. So then plus 5x minus 12, because we brought it to the other side, that now means it's less than 0. Okay, so the inequality, because you've moved this over here, that means now the inequality sign, the 0 switched as well, so it's now less than 0. Okay, doesn't make a difference with solving. So same process. So we want two numbers, so we want to find 3 times negative 12, negative 36, two numbers that times together to make negative 36 and add together to make 5. So 9 minus 4. Yep, that works. So then we're going to have a plus 9x minus 4x minus 12 less than 0. Factorize, so 3x, x plus 3, and then minus 4x plus 3 is less than 0. So 3x minus 4x plus 3. I'm just going through these quadratics a bit quicker because I'm hoping that if you're aiming for that grade 8, grade 9, this factorizing quadratics should be pretty second nature. And if it isn't, just go over it again, because all these harder questions, if you're getting that grade 8, grade 9, you need to have your quadratics just straight away. Okay, it's going to save you so much time. It's going to make a lot of things easier as well, assuming you're then taking A-level maths as well. Good skill to have, so practice them, practice them. Okay, so now we have our quadratic. Let's solve for x. So x is equal to 4/3. X is equal to negative 3. Okay, same thing. Let's now think about the inequality. So less than 0, let's set up the graph, and so negative 3, let's say it's about there, 4/3 about there. The intercept would be negative 12, but we're not too worried about that for this question. So 4/3 there, and negative 3 there. And again, it's less than 0, so it's going to be under this curve here. And if we were to write it as our inequality, x is less than 4/3 and greater than negative 3. So we have our two inequalities. If we just look at that one again, it was this one. X is less than 5/2 and greater than negative 5/2. Then how we put this together, we want to make one inequality, right? Because if we look at the question again, it says and set of possible values for x for which both quadratics and. So you need to find a single inequality statement. And the way to do this, the easiest way, is we want to find the smallest range. Not the largest range, but the smallest range. So in this case, our answer is going to be negative 5/2, because that is less, or it's smaller than negative 3. Okay, is less than x, greater than x. No, x is greater than negative 5/2. Sorry, and then is less than 4/3, because 4/3 is smaller than 5/2. Okay, when I'm being ticklish with my smaller, I mean closer to 0. Okay, so that is going to be our final inequality. We want to pick that range of which our x values are the smallest. Okay, not the largest, but the smallest. Okay, so that was with that question. Just a quick debrief. If you're not sure about inequalities, but you know how to solve quadratics, that question's 4 marks. You're going to get 2 or 3 marks just by factorizing both of those and solving for x. Okay, and then the extra 1 or 2 marks will come from inputting it into the inequalities properly. So I expect most of you will be able to find this inequality, and hopefully you'll be able to find this inequality as well. But then the final mark comes from putting it in this final inequality there. Okay, so we need to make sure we're doing that. Great. Okay, so now let's move on to what I think is probably the hardest question out of the three, and probably one of the harder questions which I've seen in the GCSE for a long time. Okay, so how are we going to go about doing this one? First of all, let's think about our trigonometry. So the centers of the circle A, B, and C, and a radius of 4. So if we set it up with our triangles, okay, so I know that A to B is 4, and B to C is also 4, because they're radiuses, right? That's the center of A, that's the center of B, that's the center of C. So that's going to be 4. That's going to be 4. And then A to this joint where A and B meet here, that's going to be 4 as well, right? Because that's the radius of A. And then this here, that's not radius of A, but it's the radius of B. So from B to the edge there, it's also 4. And then it's just going to be the same for the rest of them, right? That's 4, that's 4. Then if we go down here as well, so from A, center of A, down here, that's a radius, so that must be 4. From B down here, that's a radius of B, so it must be 4, and so on, right? So now we end up with shapes like this, where we have 4 equilateral triangles. But do we? We can make some more. So we know that this bit along here is also going to make some equilaterals. And we know they're equilaterals because all the sides are the same length, right? So the inner angles are going to be 60. So then how do we go about solving this? So what we want to find, if I then rub some of this out, I'll keep the left hand side of it, just so you can see what I'm talking about. So we have our equilateral triangles there. Just remember that goes along the whole way. But we want to find this bit here, the shaded bits. Well, what we find is if I was to draw this like that, where the green is, what we have there is a sector of a circle. Ignore the shaded bit for now. Just along here, the bit I've shaded in green, that is a sector of a circle. Okay? But then, if we look, we also want the sector of this circle as well. And our shaded area are within these 2 sectors. Sorry, it should be curved like that. It's within these 2 sectors. But we also have equilateral triangles, so we need to somehow put these bits together. And the way we do that is we know that this curved sections in here and in here is the same as that curved section at the bottom of the sector. Okay? And that, when you take that away, is the equilateral triangle. So what I'm essentially saying is the sector minus the equilateral triangle is equal to that segment of the circle. Okay, so this bit down here, I'm not just coloured in green, maybe I'll do it in a different colour, make it a bit clearer. Let's go yellow. This bit down here in yellow, that is our segment, and it is the same as these two little segments here. And then once we take away those two segments, the ones that I've now just left from the sector, we get the shaded area. Okay, but first let's work out the area of the sector and the area of the equilateral triangle to then find the area of the segment. Okay, so let's start with the sector. The area of the sector. To find the area of the sector, we start with pi r squared. And what is the angle of our sector? Well, we know it's part of an equilateral triangle, so it's going to be 60. And it's the angle, and the total angle of the circle is 360. And we know our radius is 4, so it's 4 squared times pi times 60 over 360. And it wants it in pi, remember, because it's non-calculator paper. So we have 16 times 60 over 360 pi. 60 over 360 is the same as a sixth, so 16 times a sixth pi, which is 16 over 6 pi, which again we can simplify to 8 over 3 pi, and it would also be centimeters squared. So that's the area of our sector right there. Okay, so now let's do the same for the equilateral triangle. So area of the triangle. So then if I draw that, so it's 4 centimeters, and they're all 60 degrees, right? Because it's an equilateral triangle. But the area of a triangle, I know in the mark scheme, if you look at the mark scheme for this, they've used the half AB sine C, which you can do, but what I don't like about that, which you should know anyway, but it requires you to know sine 60, the value of that. But for me, this is a far more foolproof method if you forget your sine, cosine, tan values. Okay, so the way I'm going to do it is the area of a triangle is half base times height, right? Well, we have the base, we just need to find the height. Well, to find the height, it's going to be Pythagoras. So we know that the hypotenuse is 4. We know that A is 2, or B is 2. It's 2. Okay. And we want to find the height. We know that's 2 because we could also draw the height like that down the middle of the triangle, right? And it would be splitting that 4 in 2. So that's where I've gotten 2 from. So to find the height, it's 4 squared minus 2 squared is equal to 8 squared. So 16 minus 4 is 8 squared. 16 minus 4 is 12. Square root of 12 is h. Square root of 12 is root 4 root 3, which is 2 root 3. So now we have our height, and we can find the area. So half times 4 times 2 root 3 is going to be 4 root 3. Okay, so 4 times 2 is 8, half of 8 is 4, so 4 root 3 centimeters squared is the area of our triangle. Okay, and what did we say? We want to find the segment. So we have the area of the triangle, and we have the area of the sector now. So again, if I just rub all this out here, just to try and make it as clear as possible, because it can be sort of tricky to visualize. So this is our segment, okay? We can all agree on that. That is a segment of a circle, right? That is a segment of a circle. But we want to find, and then if I just overlay on top of that, this is our equilateral triangle. So we've now found the areas of both of them. And then this bit down here is our segment, which we want to find the area of, because our segments are the same as these bits up here. They're the same. Okay, I've done them in blue. They're the same areas. So once we know the area of the segment, we're one step closer to find the total. So to do that, we have to do the the sector minus the area of the triangle. So the area of the sector, so let's just do segment area. So 8 over 3 pi minus 4 root 3. And that is the area of our segment. Because unless you have a calculator for this exam, which you shouldn't, that's as much as we can do. Okay, because we're keeping it in terms of pi as well. So that is the segment area. And that's why this what puts this question into that 5-mark range. Okay, this bit here, because then this is where we need to start thinking about how to find the shaded area. So shaded area. So if we think about looking at this, so we know that there's two sectors here. So like this, right? So we've got two sectors, and then we have two segments there, and then two segments there. So what do we have? We have two sectors and 4 segments, and we need to take those 4 segments away from the 2 sectors. Alright? Hopefully that's clear, because it's the sectors of the B circle, and then they're the segments, because it's equal to these bits down here. Alright? Let's draw that again. So we want to do 2 sectors minus 4 segments. So let's write that down. 2 sectors minus 4 segments. And the area of our 2 sectors, 8 over 3 pi minus 4, and then the segment formula, which you have up there, which is 8 over 3 pi minus 4 root 3. Then we need to expand that. So 16 over 3 pi minus 32 over 3 pi plus 16 over 3. Don't want to come all this way and forget that negative 4 times negative 4 is positive 16. Alright, so and we can simplify that a little bit more. And so that's going to be 16 over 3 pi plus 16 root 3. And then I'm just going to swap that round, because you would still get the marks if you left it like that. But, well, there's one thing we need to write as well, actually. Hopefully you can all remember what it is. I believe on the question paper it has it there anyway, so you'd be alright. But it's centimeters squared. That's all centimeters squared, because it is area that we are finding. So there we have it. Once we simplify all of that, our final answer is 16 root 3 minus 16 over 3 pi centimeters squared. That is the area of our shaded area. Okay, so let's just have a little recap on that. So there's a lot for that question. It's a lot of work for 5 marks, but that's what's going to put you over the edge to that grade 9. If you did that question by yourself, then brilliant. If you gave it a go and maybe got half of it, or you didn't get any of it, but then watched that and it started to make a bit of sense, go and give it another go now by yourself and see if you can get it by yourself, because it's quite a satisfying question. And it's just using the laws of your circles. So we know areas and radiuses. We know this is a radius. Just start there, right? Draw your radiuses. So these are my radiuses. like that, like that, like that, like that, and that's going to be a radius as well, right? Because that is a distance from A to B. It's sort of like a vector there, really. And they're all going to be 4. They're all equilateral triangles because they all have a length side of 4. And then it's just taking that leap. Once you've drawn that, then recognizing that that is a sector there. That is the biggest hurdle to climb, I reckon. But hopefully, when you saw areas of circles and you saw this strange shape here, your immediate thought was a sector anyway. And then the next bit is finding the area of that segment. And then you could have done half AB sine C for the area of a triangle. Half AB sine C, where sine 60 was equal to root 3 over 2. But you'd get the same answer anyway. So all roads lead to Rome, okay? Whichever you feel more comfortable with. Personally, I prefer using Pythagoras for that. But if you know your trig rules and your trig identities and your trig values, go ahead. Okay? So that is a look at paper 1 Edexcel grade 9 questions from the last few years, couple years. Hopefully that has helped some of you try and prepare. The best way to try and get that grade 9 is just do these questions. But don't neglect those core skills, the quadratics, the rationalizing of surds, inequalities, circle theorems, all that sort of stuff. It all plays into these grade 9 questions, okay? Because you can't do these questions without a solid base. So get your base solid, get your foundation set, and then try and get these questions going. I'll be going through some more questions, paper 2 and paper 3, and then if we need any more grade 9 questions, I'll happily do those as well. Leave any questions, and thanks for watching. Cheers.